It is only April. The peak of typhoon season in the western Pacific does not even begin until July. And yet, what just struck the United States territories of Guam and the Northern Mariana Islands was the strongest tropical cyclone recorded anywhere on the planet so far in 2026. A storm so powerful, so rapidly intensified, and so perfectly positioned to cause maximum damage that it has already drawn comparisons to some of the most ferocious systems ever measured in this part of the world. Typhoon Sinlaku did not ease its way into existence. It announced itself. And the communities caught in its path are still counting the cost. This is the full story of what happened, how this storm formed, how fast it grew, why it was so dangerous, and what it tells us about the state of our oceans and our atmosphere in a world that seems increasingly willing to produce extreme weather events ahead of schedule. To understand why Sinlaku is being talked about in the terms that it is, you first need to understand what rapid intensification means in the context of tropical cyclones, and why it is one of the most feared phenomena in meteorology. A tropical cyclone intensifies when warm ocean water feeds energy into the storm system, driving faster wind speeds and lower central pressure. Rapid intensification is defined as a wind speed increase of at least 55 km per hour within a 24-hour window. It is the meteorological equivalent of a car going from 60 to 160 in a matter of seconds, a sudden, dramatic surge in power that forecasting models have historically struggled to predict with precision. Sinlaku did not just meet the threshold for rapid intensification. It blew past it. Over the course of just a few days leading into the weekend before landfall, the storm surged from a Category 1 system, already a dangerous storm, but one that communities in this region have protocols and experience for, all the way to near super typhoon strength, with sustained wind speeds of at least 240 km per hour. That is not a gradual escalation. That is a system transforming almost overnight into something categorically more dangerous than what was forecast. At its absolute peak intensity, Sinlaku recorded maximum sustained wind speeds of 298 km per hour and a central pressure of 890 millibars. Central pressure is one of the most reliable measures of a tropical cyclone's raw power. The lower the pressure at the center of the storm, the stronger the winds that rush inward to fill the void it creates. 890 millibars is an extraordinarily low reading. For context, a completely calm day at sea level sits around 1013 millibars. The difference between those two numbers represents the colossal atmospheric pressure gradient that drives a storm of this magnitude. According to analysis from a leading hurricane expert at Yale Climate Connections, Sinlaku ranked as the second strongest typhoon on record for the January to April period in terms of wind intensity, surpassed only by a super typhoon that struck in April 2021. The fact that we are comparing this storm to historical records before typhoon season has even officially begun is a statement worth pausing on. Sinlaku also drew attention from climate scientists for another reason beyond its raw power. It was the second of a pair of Pacific tropical cyclones identified as having the potential to influence and accelerate the current El Nino event. El Nino is a large-scale climate pattern driven by warming sea surface temperatures in the central and eastern Pacific Ocean, and it has far-reaching effects on weather patterns across the globe, affecting rainfall, drought, flooding, and storm activity across multiple continents simultaneously. The relationship between powerful early-season typhoons and El Niño dynamics is complex and still being studied, but the fact that researchers are flagging this connection tells you that the significance of Sinlaku extends well beyond the immediate damage it caused on the ground. The most destructive passage of the storm was felt on the island of Saipan and across the Northern Mariana Islands. The typhoon's inner eyewall, the ring of the most intense convection and highest wind speeds within the storm structure, struck these islands directly. An extreme wind warning was issued by the National Weather Service, a designation that is reserved for only the most exceptional and dangerous wind events and is not issued lightly. Wind speeds exceeding 160 km per hour were sustained at Saipan International Airport for over 10 consecutive hours. 10 hours of sustained winds at that intensity causes a fundamentally different kind of damage than a brief peak gust. It is not just the force of the wind at any given moment, it is the cumulative, relentless pressure that strips roofing material, weakens structural connections, topples trees, and grinds down any protection that might otherwise shelter people and buildings from the worst of it. The highest instantaneous gust recorded at the airport reached 209 km per hour. As Sinlaku approached the islands, it had already developed an outer eyewall, a secondary ring of intense weather that forms around the inner core of very powerful cyclones. This outer eyewall began battering Saipan and the nearby island of Tinian with heavy rain and strong winds well before the inner eyewall arrived, meaning the islands had already been absorbing punishment for hours by the time the most intense part of the storm passed through. The mayor of Saipan described the situation publicly, and the picture he painted was one of near total chaos. Objects were reported flying through the air. Rescue operations were described as extremely difficult to conduct in the conditions. Uprooted trees had come down onto structures, particularly those with wooden or tin roofing, crushing them. People were stranded and in need of help, and the very weather that had created that need was making it nearly impossible to reach them. Guam, located south of Saipan, was also hit hard by the storm. Wind speeds at Guam International Airport reached 142 km per hour at their peak, with power lines downed across the island and roads flooded to depths of up to 30 centimeters in some areas. The Guam Power Authority confirmed widespread outages affecting residents across the island. Schools on Guam were closed not just for the day of the storm but for multiple days following it, with authorities stating that they would remain closed until the island's governor formally declared conditions safe enough to reopen them. That kind of open-ended school closure reflects the reality that the aftermath of a storm like this is not just about the immediate damage. It is about ensuring that the routes children would travel, the buildings they would enter, and the environments around those buildings are assessed and confirmed safe before people are asked to return to normal routines. One of the factors that made Sinlaku particularly destructive, beyond its raw wind speed, was its behavior in the hours before landfall. The storm essentially stalled. It sat virtually stationary for an extended period approximately 50 kilometers off the coast of the islands before it finally moved in. A slow-moving or stationary tropical cyclone is in many ways more damaging than a fast-moving one, even if the fast-moving storm has higher peak winds. The reason is accumulation. Rainfall, storm surge, and destructive winds that might otherwise affect an area for 4 or 5 hours as a fast-moving storm passes through instead affect the same area for 12, 15, or 20 hours as the storm sits and lingers. Drainage systems that might cope with 5 hours of intense rainfall become completely overwhelmed by 15. Buildings that might survive a brief peak gust are subjected to sustained structural stress for far longer. The slow movement of Sinlaku meant the islands absorbed that punishment for an extended period before conditions finally began to improve. There was, however, one significant factor that almost certainly limited the scale of the disaster. In the 24 hours before landfall, Sinlaku underwent what is known as an eyewall replacement cycle. This is a natural process that occurs in very intense tropical cyclones where the inner eyewall, ring of the most violent weather at the storm's core, collapses and is replaced by the outer eyewall contracting inward. During this process, the storm temporarily weakens. Sinlaku dropped from Category 5 strength, with winds of around 280 km per hour on Monday morning, to Category 4 strength, with winds of approximately 233 km per hour, by Tuesday morning. It was no longer classified as a super typhoon. This matters enormously. According to established damage models, wind-related destruction scales with the square of the wind speed, meaning that as wind speed increases, damage does not increase linearly but exponentially. Working that relationship in reverse, the weakening that Sinlaku underwent theoretically reduced its potential damage output by more than 4 times compared to what it would have caused at peak intensity. 4 times. That is the difference between severe damage and potentially catastrophic, generational destruction. The eyewall replacement cycle likely saved lives and spared communities from a far worse outcome, even though what actually occurred was already devastating. Even with that weakening, the projected rainfall and storm surge figures were serious. Saipan and Tinian were forecast to receive between 38 and 63 centimeters of rainfall, enough to trigger widespread flash flooding and coastal inundation. Storm surges of 3 to 4.5 meters above normal ground level were forecast for parts of the affected coastline. A 4.5-meter storm surge arriving in darkness, in the middle of sustained violent winds, in a community where roads are already flooded and power is already out, is a life-threatening event. In Guam, storm surges of up to 90 centimeters were projected alongside rainfall totals of 15 to 30 centimeters and sustained tropical storm force winds. These are not minor inconveniences. They are conditions that require people to be off the streets, away from windows, and in the safest available structures they can find. Disaster declarations were approved at the federal level for both Guam and the Northern Mariana Islands, opening the door for federal support and resources to be directed into the region. FEMA was placed in the lead coordinating role and deployed personnel and equipment ahead of and during the storm. Federal agencies issued clear and direct public guidance: stay indoors, do not enter floodwaters under any circumstances, and understand that even after the storm's closest approach has passed, dangerous wind and flood conditions can persist for many hours. In terms of its forward trajectory, the forecast has Sinlaku moving out into the open Pacific Ocean well to the east of Japan, turning northward and then northeast as it leaves the region. This path is expected to take it away from any further populated land areas, and the storm is projected to weaken as it moves over cooler waters and loses the warm ocean heat that has been feeding it. But the question that lingers after an event like this, and it is a question that meteorologists and climate scientists are increasingly asking out loud, is why a storm of this power is appearing in April. The Western Pacific can produce tropical cyclones at any time of year. That is not new, but a near super typhoon with a central pressure of 890 millibars and sustained winds approaching 300 kilometers per hour, arriving before typhoon season has even officially started, is not a normal April event. It is a signal. The ocean temperatures that fuel rapid intensification are measurably warmer than they were in previous decades. The atmospheric conditions that allow storms to escalate from manageable to historic in the span of a few days are becoming more frequently present. Sinlaku is not an isolated data point. It is part of a pattern that the communities living in the Western Pacific, communities that have already lived through some of the most powerful storms ever recorded, are going to have to reckon with in the years ahead. The damage assessment across Guam and the Northern Mariana Islands is ongoing. Recovery will take time. For the people who sheltered through 10 or more hours of violent winds and flooding on islands that sit in the middle of the Pacific Ocean, this was not an abstract weather event. It was their homes, their streets, their schools, and their lives in the middle of it. We will continue to follow the recovery from Sinlaku and bring you updates as the situation develops. If you want to stay informed on natural events like this from around the world as they happen, subscribe to Nature Report. We cover what matters, clearly and accurately, every time.